Hey, what is up everyone? I hope all of you are doing great. And in today's question, we have a uniform cylinder of mass m and area of circular section S is floating, partially immersed in a non-viscous liquid of density ρ, occupying some volume of a beaker of circular cross-section S. So this beaker also has a circular cross-section of cross-sectional area S as shown in the figure. The beaker rests on a horizontal tabletop. If the cylinder is slightly displaced either up or down and then released, it will oscillate. Find the angular frequency of this small amplitude oscillation of the cylinder. Okay, fine. Now here the cross-sectional area of this cylinder is comparable to the cross-sectional area of the beaker. So movement or moving up and down of this cylinder will cause the change in height of the liquid column, right? So let us consider the equilibrium condition initially. I have already drawn the diagram for saving you some time. So this is the condition for equilibrium. Okay, so let us consider that x naught amount of or x naught length is already under the water. So we can write that the weight of the block is balanced by the volume times density of the liquid times G. Okay, so this is our first equation during equilibrium condition. Now if this cylinder is slightly displaced or displaced by some amount and released, we see that it will oscillate, and while this cylinder oscillates, the height of the liquid also changes. Okay, so at some point of time when it is below by amount, where it is brought down by an amount x from its initial position, okay, the level of water increases by an amount x prime. Okay, so the volume of the block that is immersed inside the liquid, same volume of water basically rises above the initial level. So we can write this volume, that is S times x, okay, will be equal to this volume. So this shaded volume will be equal to capital S minus small s times x prime. So x prime is equal to S divided by capital S minus small s times x. Okay, now we just need to write the net force that is acting on the cylinder. That is, one is gravity downwards, taking the downward direction as positive side, minus force due to the buoyancy of the liquid, due to the liquid. So the total volume that is already immersed, that is immersed inside the liquid, is small s times x prime plus x naught plus x. Small s times x prime plus x naught plus x. Okay, density of the liquid times G. Okay, so we can just cancel out this one. So we have x prime as plus x rho G, we get minus s minus capital S small s rho G times x. Okay, so we can write F net equals mass times acceleration. So we have this one, capital S minus small s times x. So the final expression for acceleration is divided by m capital S minus small s times x. So this is the expression for the acceleration, considering the motion is having small amplitude. So if we compare this our traditional form of acceleration for a particle performing simple harmonic motion, where omega represents the angular frequency, so our final result would be root over rho G divided by m times capital S minus small s. So this will be our final result. So I hope you all have found this video helpful and informative. If you like the video, please do subscribe, share it with your friends, teachers, and see you in the next one. Peace.